because I've made it, there's a deadline for the time, so please complete that. What is it? Okay, so in the last class we were discussing about synchronization, so we'll continue from there. If there is any question, so you can ask it right now. Otherwise, we'll continue with the lecture. So in the last class, we were discussing about producer-consumer problem, and we said how semaphore can be used to solve this problem. Now, because this particular problem requires event synchronization, so mutex cannot be used to resolve the issue, and we need semaphore construct here. Today, we are going to discuss two other problems, readers, writers, and sleeping barber problem. Of course, three problems, dining philosopher's problem. These all are known as synchronization. Now, so producer consumer, as we discussed in the previous class, that one process is producing some item and writing on a buffer, and another process is consuming items from the buffer, and buffer is of finite size, so this is known as bounded buffer producer consumer problem. So where these could be that there are multiple applications. For example, if you're looking at a compiler will be consisting of different functions, and one of the function is the pre-processing. So pre-processing is reading some input and producing the output, and this output is being consumed by the parser for the next phase. Similarly, a barcode reader is reading barcode, and this is being sent to the device driver. Printing file data on a printer, so file data is being sent from the computer to the printer. So computer here is the producer and the printer is the consumer. Similarly, web server, you're trying to read a web page, so web server is sending some data to the browser, and browser is the consumer here. There are many applications of the producer consumer problem. And in all such cases, consumer has a buffer which will buffer the data coming from the producer and read it in the sequence in which the data is arriving. Then a related problem is readers writers problem. So the difference from the producer consumer problem is that there are multiple readers and multiple writers. And in case of producer consumer problem, because each consumer is consuming item, it is deleting an item from the buffer. So naturally, at any time, your critical section can have either a producer or a consumer. So even if there are multiple producers and multiple consumers, at a time, the critical section can have only one producer or one consumer. So there might not be two entity at the same time in the critical section, be it producer or consumer. But readers, writers, so writers are producing, writers are writing something to a common area, and readers are reading from this common area. So readers are just reading, they are not deleting any data. So it might be that writer is writing to a database and readers are reading from that database. And there are multiple readers, multiple writers. The only difference is that now if you look at the critical section, there can be only one writer at a time in the critical section. There can be multiple readers, but there should not be any writer at that time in the critical section. So once the writer is in the critical section, no other reader or writer is allowed. But if a reader is in the critical section, we should not be saying critical section because no change is being made to the shared resource. So when a reader is reading, the other readers are allowed to come to the read. So we can consider it like a library in which the writer enters the library to write something. But as long as writer is in the library, the readers cannot enter the library. But if a reader is in the library, then writer can enter, but other readers can come and enter. So now it is up to the reader to ensure that when they leave the library, they allow a writer to come back. But it goes in as the other writer not coming. But it will not talk to reader. So this is the solution that we need to make. And an application of reader writer is, like I said, in databases, there are multiple processes trying to update the data. For example, online banking system. So many people are trying to do the banking. So the banking software has to cater to write request as well as read request from the different users. So actually, if a read request is being served, the other read request can also be served because they're not making any changes to the system. But once a write request is being served, the other write request and read request should be stopped. So online reservation system and any system where database is being accessed and some processes are trying to write or some processes are trying to read is coming into this category. So there are multiple solutions for readers and writers. And we'll be discussing 3 solutions. The very first solution that we are going to read gives preference to the reader. So it is biased towards readers. This is the reader's preference solution. So in this solution, we are going to use 2 binary semaphores and 1 counter. This counter is going to basically check how many readers are right now in the reading area. And because we are using these semaphores as condition variable, sorry, we are using them as controlling the access to the critical section. So these semaphores are initialized to 1. So let's look at writer. Writer code is very simple. So writer is waiting on a semaphore called resource. And if this resource is available, then if the value is equal to 1, it will decrement it. And so this value now becomes 0, and then it will enter the critical section. And now because a writer is in the critical section and the value of resource is now 0, other processes cannot enter and they will be queued into the queue corresponding to resource semaphore. When the writer comes out of the critical section, it will increment the value of the resource. So now it becomes 1 again, and all the processes which are sleeping on that semaphore will be awakened. Either all of them or one of them will be awakened, depending upon how the semaphore has been, signal method of the semaphore has been written. Another semaphore, this is the binary semaphore, is our mutex. So what is the strategy that we are going to follow here is that if a reader is in the critical section, sorry, if writer is in the critical section, the reader has to wait. Okay, and actually when the very first reader comes, it has to be blocked if the writer is in the critical section. If the writer is not in the critical section, then the first reader has to ensure that writer is blocked, and then it will enter the critical section and allow other readers to come inside. Once the reader is in the critical section, the writer cannot enter because the first reader has already blocked the writer. Now when these readers are done with the reading, they will start leaving the reading room, and the last reader to leave the reading room has to ensure that that critical section entry is again inward. So the first reader has to ensure that entry to the critical section is blocked, and writers are forced to wait on that semaphore. Similarly, the writer also has to ensure that the very first reader is blocked in entering the critical section. In fact, the readers, as I keep on saying, is not the critical section. Readers are not, there is no critical section in the reader when it comes to reading. So what the reading room right now, we will be considering as the critical section for the reader also. So now how the reader will know that it is the first thread or it is the last thread? So reader will keep a count. So so whenever a reader executes the code, it will increment the count. And it means it is the first reader. Okay, and once the readers have started, so if a reader is already in the reading area, other readers can come and keep on incrementing the count. Whenever a reader leaves the reading area, it will decrement the count. So when the count becomes 0, the reader knows that it is the last reader, and then it will do the necessary. So naturally, because this read count, which is keeping the track of the number of readers who want to enter the reading area. So at any time, the read count is the number of readers which are either in the reading area or trying to enter the reading area. Okay. So whenever a reader wants to, so this read count is a shared variable between different readers, and reader threads are actually, or reader processes are actually incrementing or decrementing this variable. So accessing this variable is the critical section. So we have to protect this critical section, and therefore we are using another semaphore, which is rmutex. So before, when a reader wants to enter the, wants to read, it will try to see whether someone is trying to increment, whether someone is trying to change the value of the read count. If not, it will enter and increment the read count. Then it will check whether this is the first reader or not. If it is the first reader, then it will execute wait resource. Now, because the resource was equal to 1, now it becomes 0. So it is essentially blocking any writer from entering the critical section. And then it will signal, it will increment rmutex, allowing other readers to change the read count. Then here the readers are going to do the reading. And once the reader exits the reading area, again it has to decrement the number of count. So it will actually try to see whether rmutex is equal to 1 or not. If not, then it will be queued here. So some of the readers might be queued here, some of the readers might be queued here, and one of the reader will get the chance to update the value of read count. So when a leaving reader gets the chance, it will reduce the number of reader. At the same time, it will check what is the value of the read count. If it is the last reader, then it will signal resource. Now, writer wishes, it will enter the critical section. But if writer thread is not available, another reader comes. So again, this becomes the first reader and again block the resource. That's how the program works. So actually, once a reader is doing the reading, as long as a reader is doing the reading, the writer is blocked and reader can keep coming. That's why it is known as reader's preference solution. Any questions? Any question? Deepak? Okay. So this is the description of the solution. You can go through it. And if there are any question, we can go through it. Second question is actually towards the writer's preference. We will give the preference to the writer. So here the idea is the same. The very first writer, that's the critical section, will force readers to block. And then when the writers force readers to block.